Now we will consider the takeoff phase on which at V1 the captain decides to continue the takeoff. Let us consider that this is the runway and this is the end of the takeoff distance available. This distance is considered as takeoff distance available, TODA. My aircraft will line up here and will release the brake. This is the brake release point. From the brake release point, I will accelerate with two engines. At one point of time, the engine will fail, that is at V engine failure. Now, consider that I'm gonna continue the takeoff at V1 speed. That is at V1 speed, the captain has decided that he will continue the takeoff. 1 second gap is there. So now what is going to happen is that at V engine failure, there will be asymmetry in the thrust or the power. Power in case of a propeller engine when it has got a critical engine. So let us say that this is a critical engine for the propeller. For a Z engine, it can be either way. But for example, I'm taking that this engine has failed. But this engine is going to produce the maximum amount of thrust, that is at TODR thrust. This has failed, this is producing thrust. The aircraft will swing onto the left in this case. My aircraft will start going onto the left in this case. So I need to consider the speed, which is the CAS, okay, at which the captain of the aircraft is able to control the direction of the aircraft with aerodynamic controls only. On ground it is rudder only with a force on the rudder not exceeding 150 pounds, and considering the crosswind of 7 knots from the fail engine side, and the operating engine at takeoff power or takeoff thrust. That speed is what we call it as the minimum control speed on ground, VMCG. So my consideration of the V engine failure has to be above the VMCG because I need to control the aircraft. So I will consider the V engine failure above VMCG, at or above VMCG. In the VMCG, if I have to control the aircraft, if I have to bring the aircraft parallel to the center line, the maximum displacement from the center line should not be more than 3030 feet. Thereafter, at V1, I decide to continue the takeoff. So therefore, I will rotate at VR. If I rotate at VR, the aircraft will lift up at VLOF. This is the lift-off speed, and the aircraft has to finally reach V2 by 35 feet at or before the takeoff distance available. This distance from the brake release till the time the aircraft reaches V2 by 35 is what we call it as a TODR N-1 on a dry. If there is no engine failure, I will still get airborne and I will still reach V2 by 35 feet. That is in case of all engines operational. So obviously that will happen before this. Since I have got all engines operational, okay, if I continue the takeoff, I will reach V2 by 35 feet before this place, which was considered using one engine inoperative. If I have to consider all engines operational and the distance required for me to reach V2 by 35 feet with all engines operational will have to be given a margin. The margin given is 15%. So in this distance, if I add 15% of margin, and I arrive at the distance, this distance is what we call it as a takeoff distance required, okay, with all engines operational on a dry runway. Now, let us consider takeoff on a wet runway or a contaminated runway compared to that of a dry runway with one engine operational. Now, this is the brake release point. My aircraft will accelerate with two engines and the wheel have to be above VMCG or equal to VMCG. I will have the V engine failure here. It will take 1 second for me to recognize, and I decide to continue the takeoff, and will have to reach the V2 by 35 feet. Okay, this is the takeoff distance required, okay, and has to be lesser than the TODA. And let's assume that, okay, I'm able to reach V2 by 35 feet exactly at the end of the takeoff distance available, which is considering the optimization of the takeoff weight.
Yes.
This is on a dry runway.
Yes, yes.
Now let us assume that it has started raining suddenly. And considering the same condition, I know that if the runway has become wet, the aircraft will take some more time to accelerate.
Yes, sir.
Okay, so therefore, okay, I will not be able to reach the V2 by 35 feet here, and I will be able to reach the V2 by 35 feet somewhere here, which is beyond the takeoff distance available, which is not safe and which is not allowed by the regulator.
Yes, sir.
So the option what we have is, again, as we discussed earlier, lesser the weight, lesser the distance required, more the weight, more the distance required.
Exactly.
So I will have to give a penalty in terms of weight. So I'll have to reduce the weight of the aircraft by some, let us say that 1,000 kgs once again.
Yes, yes.
So now the regulators give a concession to the operators that whenever the runway is wet or contaminated, instead of measuring the distance from brake release up to this point where you reach 35 feet, okay, you can afford to measure the distance up to the place where it reaches 15 feet. 15
Yes.
feet, okay. However, I am still required to reach the V2 at 35 feet at all times. Reaching the V2 at 35 feet, irrespective of runway, is whether it's dry or wet or contaminated, I will reach the V2 always and always at 35 feet.
Okay, sir.
However, for measurement of the takeoff distance required, the distance will be measured from the brake release till the time the aircraft crosses 15 feet. That is what we call it as a reduction of the screen height from 35 feet to 15 feet. So now
Yes, yes.
I have reached the 15 feet here. This distance is what we call it as the takeoff distance required, okay, TODR, with N-1 on a wet or
Wet.
contaminated runway where I have used the credit for reduction of the screen height to 15 feet.
Yes, yes. What is it?
In this case, my reduction in the weight penalty is much lesser as compared with the previous one, say
Yes, yes.
200 kgs. So instead of reducing 100,000 kgs, I can afford to reduce only 200 kgs and take off safely.
Yes, yes.
Now, another consideration is that it also may happen so that because of the reduction of the screen height from 35 feet to 15 feet on a wet or contaminated runway, my aircraft is able to reach the 15 feet here.
Yes, sir.
15 feet here. That is before the takeoff distance available.
Yes, sir.
So in this case, once again, theoretically speaking, I can convert this leftover distance into the weight.
Okay.
Okay, I can put additional amount of weight theoretically.
Theoretically.
But this adding of additional amount of weight, okay, because of the very fact that I have utilized the concession of reducing the screen height to 15 feet, is not allowed. I repeat, not allowed by the regulators. Once again, so if therefore the weight on a wet runway or a contaminated runway should never exceed the weight on a dry runway because of the use of the credit. That what kind of a credit? Reduction of the screen height to 15 feet.
Yes, yes.
So that check is we are doing it. This is another part of a dry check considering the continuation of takeoff.
Confusion. Yes, sir.
So the
Sounds
dry
right.
check will have two components to it. One is that because during the reject takeoff, because of the use of reversers, and during the continuation of takeoff, the reduction of the screen height. So
Screen.
combine this together, we will say that on a wet or contaminated runway, because of the use of the reversers on during the reject takeoff and because of the use of the reduction of the screen height, I may be able to carry additional amount of weight theoretically, which is not allowed by the regulators.
Regulator.
So I need to check whether that weight on a wet or contaminated runway is more than that of a dry runway or not, and we'll have to take the lesser one accordingly. So this check is what we call it is a dry check, complete dry check.